of pressure. As you can see, 1 atm. So 1 atm, 1 atmospheric pressure can be expressed in bar. So it is almost 1 bar. 1 atm is almost 1 bar. But as you can see, a difference is 1.01325. So as it is almost equal, it is some cases we used to take 1 atm is equal to 1 bar because it is 1.01. But the SI unit of pressure is Pascal, PA, Pascal. ATM, even though we use commonly, the SI unit of pressure is Pascal. So it can be kilopascal and Pascal, both are related. You can see only kilo mean 10 raised to 3. You have to add extra. So 1 atm is equal to 101.325 kilopascal, or sometimes they used to write 1.01 into 10 raised to 2 kilopascal. That is the shortcut way, 1.01 into 10 raised to 2 kilopascal or 1.01 into 10 raised to 5 pascal. Kilo means like you have to divide it with 10 raised to 3. That is the only difference. And pascal is the SI unit of pressure. And the third unit for the pressure is torr or millimeter mercury. Both are same. 760 torr is 1 atm or 760 millimeter mercury is 1 atm. So that is the only difference. So basically 3 different or 4 different pressure units you can say. ATM, that is a commonly used because 1 atm is the atmospheric pressure. That is why ATM stands for atmospheric pressure, ATM. And that is the commonly used one. And you can convert it to other units of pressure in this way. 1 atm is almost equal to 1 bar, but not exactly 1.01325. And pascal and kilopascal, as you can see, again it's 1.01 into 10 raised to 5 pascals or 1.01 into 10 raised to 2 kilopascal. Sometimes some like kind of question they used to give it, especially in the entrance test and all, where it's very difficult in a like a competitive exam to multiply this one with the this one without the calculator with the digits 0.01. So some cases they used to write 100 kilopascal or 10 raised to 5 pascal is 1 atm. So they used to round it and use, or when you're preparing for competitive exam, no need to go for 1.01 because it's taken as 100 or you can say 1. So you can either write 100 kilopascal or 10 raised to 5 pascal. That is another shortcut way. And especially when you're doing the calculation without the calculator, that will be easy for calculation. So some textbooks, some website resources you will find they're using 100 kilopascal or 10 raised to 5 pascal because they round it and use it like that. Okay. So these are the different units of pressure. Is it clear? Yes, Zuhair? Next one, most of the yes.
How does millimeter mercury pressure?
It's used with the mercury. This one, how you know the temperature thermometer scale with the mercury, right?
Yeah.
Similarly, in that way with the pressure. The one kind of barometer designed at that time was basically containing mercury as a metal. So we based on that. And that is not a commonly used one. Yeah.
Ma'am, will there be numericals on Dalton's law of partial?
Yeah, there will be. So we have to solve.
Ma'am, I have one doubt in that.
Yeah.
Ma'am, it won't work for gases which react in the equation, right?
Yeah, they will be, if they are reacting, then it won't be functioning because in Dalton's law, a mix of gas mean it should be non-reacting gases. That is the one condition.
Why though? Because
if they are reacting, the number of moles is differing, right? Say example, A and B is reacting C. So 2A plus B giving C. So number of molecule reacting and number of products giving is different. So there will be a change in number of moles. Number of mole change mean mole fraction will be changing. So that is not applicable when gases are reactive.
Yes, ma'am. I just had that small word. Thank
Yeah.
you.
And other commonly, like you will get confused with the value of R, gas constant, universal gas constant. As I said, 8.314 joules per Kelvin per mole, that's a standard one. And the same way you can see 8.314 Pascal meter cube Kelvin inverse mole inverse or per Kelvin per mole. That means 8.314 is the SI. If you're taking the SI unit of all the quantities, right? Temperature, pressure, volume, whatever, the unit of R or the value of R will be 8.314. If you are using the pressure in terms of bar, okay, in that case you can see, or the pressure volume is in liters or dm cube, because dm cube and liter is equal. They are same. 1 dm cube is 1 liter. So they are same. So you can see the one which is highlighted in blue, the same. Because only thing is that the liter and dm cube is different, but actually technically both are correct. 1 liter is equal to 1 dm cube. That is the reason why both are same. 8.314 into 10 raised to minus 2. That will become 0.083. And when you are...
Ma'am, so both those values are the same.
Yeah, same thing only. If you multiply 8.314 into 10 raised to minus 2, what you will get is 0.08314, right? So that is what. Only thing is that instead of L liters, we have used DMQ. And the last one, which I shared already, when you are using liter atmosphere, ATM as the pressure unit. ATM. So in the first two, it was like basically SI unit Pascal. And the second one, we were using bar pressure. Pressure unit was bar. And the last one, ATM pressure. So it's based on that you can choose.
Ma'am, wasn't first one joules?
Yeah, that is, see, joules is a SI unit of energy. So in that way only. And in the numerical, it will be given, but still I'm telling you, like it will be given the value of R, which value should be used. But if in case it is not given, you can use like this. So surely one numerical will be there with related to ideal gas equation. Ideal gas equation means you have to use the R value, and mostly it will be given. Okay, so let's start. I'm not interfering now. Just take 2 minutes time and check whether you're able to solve it. Then we'll have a discussion. No, this is different. These are different questions. Worksheets are already uploaded that are contains different questions. This is a different one. This is related to Dalton's law. So first you have to identify what is the question and which law is related, because they are talking about a neon and dioxygen mixture. Dioxygen means O2 gas, which is also known as dioxygen because it is two oxygen atom in a molecule. So sometimes they refer it as dioxygen. So neon and oxygen mixture contains 70.6 grams of oxygen, 16.7 grams of neon. If the pressure of the mixture means, this indicates total pressure. Pressure T, total pressure. Now you have to calculate the partial pressures of oxygen and neon. It's a direct question, nothing is there indirectly given. And as the pressure is given in bar, partial pressure also, you will get the answer in bar or bar pressure only. No need to change. Dheeraj, how you will start solving this question? Dheeraj, you're there?
Yes, ma'am.
Yeah, how you will start solving? It's a 3-mark question. Just say example, if in the exam it will come as a 3-mark question, what you will find first?
Ma'am, the number of moles.
Okay, number of moles, very good. You have to start with number of moles and make sure that in your exam, writing the equation carries marks. So even if you don't know how to solve till the end, but if you know the equation directly, Dalton's law equation, write down those equations. All the equations what is related to this, you can write it down. If you're not having enough time to solve such question, at least if you're writing the equation, some marks you will get. So have a habit of writing like that. So number of moles of oxygen, you have to find mass is equal to 70.6. What is the molar mass of oxygen? Go to gas. Molar mass of oxygen.
32.
Huh? One oxygen is 16. So 2, O2 means 32. 70.6 divided by 32, right? And you will get an answer for that. And similarly, you have to find the number of moles of neon.
Ma'am, after finding partial pressure of one, can I just subtract it from the total pressure and then I can find the other?
Yeah, if you find the one of the partial pressure, then you can subtract from the 25. Total pressure is 25, right? So if you found the partial pressure of oxygen, you can find the partial pressure of neon. Yeah, that is fine. Or otherwise, you can do it. Even like mole fraction also, you can do the same way. Because total mole fraction will be 1. That is a one concept. So if you're finding first neon, here it will be 16.7. What is the molar mass of neon? Molar mass.
20.
10 is atomic
20.
number. Molar mass is 20. Yeah, yes, Siddharth, correct. So you're getting number of moles. After the step, next step will be, so finding the number of mole is the first step. Second step is finding the mole fraction of oxygen. For that, what is the value, number of moles of oxygen? How much you're getting?
2.20.
2.2 here, and here for neon?
0.8.
0.8. So here it will be 2.2 divided by 3, almost. Because number of moles of oxygen divided by total number of moles. So you will be getting around 0.7 something, right?
0.7.
0.7. What is the next digit? Or you can write it as 0.7, almost, because 370. Yeah, 10. 70. Okay. This is the mole fraction of oxygen. So mole fraction of neon will be 1 minus.
So 0.27.
Because in any mixture, total number of moles will be same, is equal to 1. So number of moles, sum of mole fractions will be equal to 1. That you can see here. So 1 minus. Otherwise, you can find in another way, like mole fraction of neon can be found out like number of moles of neon 0.8 divided by 3. That way also you will get the same answer. Now,
So better find partial pressure now, right?
now you can do the partial pressure here.
So 0.73 into 25.
Yeah, so partial pressure of oxygen is equal to 0.73, that is the mole fraction, into 25. That is the total pressure. Similarly, partial pressure of neon will be?
Total 25 minus PO2 rate.
Or you can do the other way, 0.27 multiplied with 25. The other way you can do. direct equation. Use the equation and do it. If you do the other, because it's only a mix of two gas, you can say after finding the partial pressure of oxygen, 25, that is the total pressure minus partial pressure of oxygen will give you partial pressure of neon, because it's a mix of only two gases. If it is 3 or 4, then you have to individually find.
Ma'am,
Yes.
ma'am, could you explain again why did you divide 2.2 by 3?
Mole fraction, what is the equation? Mole fraction, to find the mole fraction. What is the equation, Vishesh? Only 3, yeah. Yes, Vishesh, how to find the mole fraction? What is the equation?
Ma'am, I don't think I remember.
That is the problem. Number of moles of that particular component. Say example, you're finding mole fraction of oxygen. Mole fraction of oxygen means number of moles of oxygen, which is equal to 2.2, which is the number of moles of oxygen, 2.2, divided by total number of moles. Total number of moles mean 2.2 plus 0.8, because you have two components in mixture. So that will come as 3. 2.2 plus 0.8, it will come 3. So number of moles of that particular component. For example, you're finding the mole fraction of oxygen mean 2.2 by total number of moles. Similarly, if you want to find the number of moles of neon, then it will be 0.8 divided by total number. Total number will be same. Like,
Yes, ma'am, I recollect.
okay, good. So what is the final answer? Partial pressure
Ma'am,
of
I got PO2 is 18.75.
18.25 and
Oh, sorry, 18.25 and
is equal to
6.75.
6.75.
Yeah.
Yes, ma'am.
So you will get like that, yeah. 18.25 for oxygen, 6.75. So these are the two values you are getting.
Ma'am, in the exam, maximum mark for one question will be 5 marks, right? Like there will be 5 mark questions, right?
Yes, I didn't get you.
No, like maximum mark for one question in an exam is 5 marks, right?
Yeah, maximum 5-mark question, but it won't be like an essay. Even 5-mark question will have A part, B part, C part. So individual question with maximum mark will be 3, like numericals.
Yes, ma'am.
Numericals will be from this chapter, it is like this. What all the things which we are discussing that way only. Theoretical mean if you see quantum numbers, where you will find a lot of things like that, and periodic classification. It is completely theory with the definition like mode length, mode parameters. That's beginning of the chapter 4 also. Numerical mean first chapter, that is again it is related to molarity. That calculation will be there. Avogadro number calculation will be there, and in this chapter you have gas laws and calculation. So that is the main basically numerical, but that is in good number. So shall we move to next one? Ready? Zuhair, you got? Okay. Next one. .05 milliliters of phosphorus vapor weighs 0.0625 gram at 546 degrees Celsius and 1 bar pressure. What is the molar mass of phosphorus? So here milliliters convert into liters. That is the first thing. Volume convert into liters you have to use. And which equation to use? Which equation is connecting molar mass with pressure, volume,
Ma'am,
and
ideal.
PV is equal to nRT.
Yes, ma'am.
Okay. And here the number of moles N is equal to mass by molar mass. And this molar mass is the one you need to calculate. Mass is given. So you have to use standard units. Milliliter you convert into liters. Temperature should be in Kelvin by add 273.
Ma'am, we have to use 0.1 0.08.
Because pressure is in bar. So which R value you have to use?
0.083, right? Into 10 raised
Yeah,
to
that
minus.
one only. Yeah.
Yeah,
You might have just wrote it down this from this table, right? This one.
Yeah.
The one which is highlighted in blue color.
So we have to use we can
Yeah,
use either.
0.083 bar dm cube means it's equal to liter, right?
Yeah.
So same thing. Or you can either write 8.314 into 10 raised to minus 2, which is equal to 0.083.
Yeah.
So convert the volume into liters and temperature to Kelvin before you start solving. Then rearrange the equation. So PV is equal to mass by molar mass RT, and you have to what you have to calculate is molar mass, which is equal to M R T divided by PV. All the values are given, and R you have to use as 0.083. Mostly nowadays CBSE started giving the units because before you were allowed to take Clark's table to the exam. Now the last 2 years they are not allowing. So because of that, in the question paper they started giving all the units, constants and all. So nothing
now
to
in
worry
the
much.
questions, in the questions they are giving the units here.
Yeah, because you're not supposed to take anything, only log table that also school will be providing from the exam center. You're not supposed to bring anything with you, like take anything with you to the exam room. And you know the reason why? Because in most of the students' class table, there will be a lot of writings. Huh? That is the reason why they they are not allowing it.
Reference material.
Okay. I hope you know how to convert milliliters to liter, right? I don't have to
write into 10 raised to minus 3. So that
yeah, or 0.034 it will come. 0.034 liters.
And if we convert to powers, we can cancel out powers. So it will be easy.
It's up to you. It's up to you how you want to do. There is no restriction on solving. Only thing is that you have to use the correct equation. You have to convert and you should get the final answer correct. The way how you want to do it, it's up to you. You're free to do it.
And temperature should be in Kelvin, right?
Kelvin, yeah. Add 273.
Over here, M is 0.0625, yeah?
You got the answer?
Ma'am, one doubt.
Yes.
Over here, M is 0.0625, yeah?
M is equal to 0.0625, yeah.
Oh, yes, I'm just confirming.
This is the mass. Anybody got the final answer? Molar mass?
Is it 123.6?
1236.
Is it?
It can't be like that.
One to 6.7.
Yeah, 126.72
7.2 or 7.
Okay, let's wait for some more.
I'm getting 124.94.
Ma'am, I'm getting 125.19.
Almost
It
somewhat.
will, yeah, I think it'll be different because 8.43, 0.083. So like depends what we take, right?
And what will be the units? That is important. In which unit you are expressing?
Won't be
Gram.
Gram,
gram,
right?
right?
Gram per mole. Gram per mole. Right.
Yeah, gram per.
Almost equal to 123. You should be getting somewhat close to 123. When it's a decimal change, that is okay, but somewhat 123 because phosphorus is it exists as a tetraatomic molecule, P4. One molecule of phosphorus, the mass is 30, somewhat 30, 31 or something. It's 30 point something. So almost equal to 123. That is the molar mass because P4, it is phosphorus with four atoms of phosphorus in one molecule. So we should be getting somewhat close to 123, maybe 122 or 124, something related to it. Slightly difference will be there because most of the units what we use is a rounded value. We don't exactly take, say, example, Kelvin scale. It's actually 273.15, but we used to take 273 for like for rounding it. So there will be slight difference. You won't get exactly 123. So that is okay, but somewhere close to that you should be getting.
Ma'am, I got 122.85.
1, 2.
122.85.
Very good. So it's almost equal to 123. Fine. Okay. So any doubt? Anybody still didn't get the answer? Like didn't get the answer?
Ma'am, the pressure value, we can use the one that's given in the question, like if it's one that we know.
1 bar pressure, yeah. It's because
Okay.
you're using 0.083, that is a universal gas constant, because its pressure is given in 1 bar. If it was in ATM or if it was in Pascal, what you will be using the other one, right? So it is based on what is the pressure unit given, you're choosing the R value, because temperature always you can convert. So based on the what is the pressure unit given, you can use the R value. So that is the easy way. Because converting a pressure is like, you can see it's a lot of the decimals are coming, it's very difficult. Okay, so one more question I just want to finish. The density of a gas is found to be 5.46 gram per decimeter cube at 27 degrees Celsius at 2 bar pressure. What will be the density at STP? So density, the first density is given. If I'm taking, it is D1, density is D, so it is D1. And temperature is 27, so T1. You have to convert into Kelvin, that is a different thing, but the first temperature of the system is given as 27. The pressure is given as 2 bar pressure, again it is P1. You have to calculate D2. So, did we discuss any relation between density, pressure, temperature, connecting these three parameters or variables, I can say?
Yes, ma'am.
What was the equation?
Mass by volume. and temperature.
See, all these things will be related to your ideal gas equation. So quickly, I'll just give you a hint so that you can start it. PV is equal to nRT, or you can say PV is equal to mass by molar mass into RT. And you know that what is density? Density is equal to mass by volume. So if you take volume to the other side, pressure is equal to M mass by volume and RT by V. That means you can write it as pressure is equal to density multiplied with RT by V. Or if you rearrange the equation in terms of density, density will be equal to PV. Sorry, it won't be a V, like M. It will be M down, sorry. It will be, this is will be N. This is M, sorry, molar mass. So you will be getting PM by RT. And you know that in this case, R is a constant, universal gas constant R, and molar mass is a fixed value. It's a constant for a particular object. Right? So example, oxygen O2, 32 is the molar mass, that's a fixed value. So it's again taken as a constant for if you're talking about a particular gas. So M, that is the molar mass, and R, both are constant. This is constant and this is constant. So you can remove that terms. So finally your equation will become density is equal to P by T. Because you're removing the constant terms, molar mass is fixed for a particular gas. It won't change at any temperature, pressure. Molar mass of oxygen is 32 or molar mass of hydrogen is 4. Like that, it will be fixed. Like that, it will be fixed. So in that case, you can get a new equation, which I can write in this way. D1 is equal to P1 by T1. So D2 will be equal to P2 by T2. Right? And from this equation, you can derive a new equation like in this way. Which is equal to D2 by D1. If you subtract or divide these two equations, D2 by D1 is equal to what you will get. D2 by D1 is equal to, if you just divide these two equations, D1 and D2 terms, what you will get?
P2 T1 by P1 T2.
P2 T1 by T1 P2, sorry, T2 by P1, right? So from this equation, you can get it. Just use that equation. Use this equation to, what you can say, get your answer. We'll discuss it tomorrow, but I'm just giving you a hint so that you can take it as a homework. And
Thank you, ma'am.
physics ma'am is waiting, so.
Thank you, ma'am.
Thank you, ma'am.
Yeah, bye. Welcome. Bye.
Thank you.
Sorry, ma'am.